Welcome, everybody. Can you all hear me okay? Fantastic. My name is Brian PONT. I work for a company called Safe Software. We're based actually out of Canada, so a little ways away from here. And I've been working in the software industry for about 20 years now, always with companies where spatial and mapping was a part of their platforms. And so today I get a chance to talk to you about kind of where spatial data fits into the modern data stack. And yeah, thanks for joining me. It's great to see you. So I'm curious to take a bit of a poll of the room. How many folks here actually work with any sort of spatial data, mapping data? Just hands up. Okay, that's like a 50-50. That's pretty impressive. So for the other 50%, this is a really good chance to start to think about where spatial data might fit for you. And for the other 50 who use it today, hopefully this is really inspirational and gives you some new ideas on things that you can do as well. So at a high level, we're going to kind of go through just some background about spatial data, what it is for those that don't use it regularly. And the best part of this is we're going to tell a few stories about what our customers are using spatial data for and how it benefits them. And the goal there is to give you a bit of inspiration, give you some ideas. And I'm really pleased today to welcome Steph STEDMAN from Transport for London. She's going to come in about 20 minutes or so and tell their story about how they're using spatial data today for flooding analysis, which is really, really interesting. So by way of introduction, I thought it'd be really good to introduce you to our company and what we do. And by the way, we have a booth kind of like just a ways over there to the left of us, so come join us. We're a fun group, happy to chat spatial data all day. But what we do is an integration data platform where we have the most comprehensive support for spatial data. And it's no code. And one of the things that we've done, I'll go to this slide actually because it tells our story a little bit better, is that we've been around for 30 years at this point. Our birthday is in December. It's coming up, so we can change this slide pretty soon. But when we started, we were really focused on how do we solve challenges around spatial data and how, for many of our customers at that time, it was in government. I've got this very specific set of data that a GIS team or Geographic Information System team, if you're not familiar with that term, is using, and I have other departments within the organization that need to use that data, and they couldn't because these things just don't talk to each other. And so that's where our company started, but of course we've branched out over the years. We have hundreds of thousands of end users using our platform. We have 25,000 organizations today using our platform as well. And so we've grown and grown and grown. Tooting our own horn a little bit more here, we were named the Customer's Choice Award for North America by Gartner. So our customers really love using our tools, and we're really proud of that, which is great. So here's the spatial bit. So our platform supports lots of different specifically spatial formats that you can connect to. And that covers all types of data: points, polygons, rasters, imagery, satellite data, 3D models, building information models. It's like the wide gamut of spatial data is pretty impressive. And so it takes a specialized tool to kind of handle that and work with it. And I love this slide too because it kind of gives the history of the field that we're all working in. So this is where our company has kind of added to the platform over time different systems. So again, we started way out here in the GIS to CAD realm, and we've just grown and grown and grown as our customers have used all kinds of new different systems. So kind of just a neat look there at where technology has gone. All right, so we're in the modern data theater here. I'm going to give you my definition of what a modern data stack is. And to me, I think the one thing that ties together the word modern there is the fact that cloud technologies have come in and just taken over the game for many, many organizations. We saw probably 4 or 5 years ago a little bit of hesitation to move to the cloud for a lot of our bigger customers. And that was around privacy and security concerns and just the newness of these cloud technologies. But today, that's changed quite dramatically, and we're seeing even our largest customers embracing cloud, moving their data to the cloud, and using all these new cloud systems. So I think cloud is revolutionary. And I think there's a few reasons why. There's the cost. You're saving tons of money by using the cloud. There's efficiency, scalability of what you can do with these tools. So it's really, really changed how things work. And I've kind of just drafted out here a few, I think, of the key pieces that I see modern data stack containing. So obviously you've got your data, and it lives in different places, and it's different file formats. But in a modern data stack, you've got to move it around. You've got to connect it to systems where it needs to go. You've got to transform it. And so there's a nice piece there in the middle where our tools are typically used. And then, of course, you're storing it into data lakes, data warehouses, databases. And it would be a really shame if that's all you did with it, if it's just sitting in one place and not being used. So the analysis side is really, really key to a data stack. And business intelligence tools are really useful here. So yeah, this is very simplified, but I think at the core level, these are the pieces that you're thinking about when you're looking at what our stack should include. So what it also should include is spatial data, because spatial is incredibly valuable. And in a way, it's kind of everywhere. Like, you are here in a room today, you're effectively kind of a point on a map, you've got a phone with a GPS. Like, we're all pieces of spatial data. Everything is a piece of spatial data. Events are happening all the time. Spatial is kind of everywhere. And one of the kind of fun things I was figuring out when I was building these slides is that in the UK, there's a reality show called Location, 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 which apparently is a fantastic real estate kind of show. So the other way you can think about spatial data, whenever I say spatial, is location. It's a place on the world that we all live in. So yeah, I got to check that show out at some point. So yeah, it's absolutely indispensable, and it reveals really helpful insights that can otherwise remain hidden from you. So to get our brains going a little bit, I've got just a few examples of spatial data patterns, or like how you would start to use this type of data. And just to walk through one of them, for example, let's say you have a set of customers and you have all their addresses, but you don't actually have the locations of where they are. So geocoding, super common method of taking that address, actually creating a point on a map of where they live, and you can create this nice user base for yourself. Similarly, once you have that type of data, you can join other spatial data onto it. And so a good example of that would be if you have demographic data, for example. You've got these big polygons that are summarizing a location. You can have all your points of your customers, have your demographic data. If you know your point lives inside that polygon, now you can join that stuff together. So just quick examples here. And of course, once you've got that, you can filter it down, you can manipulate it, do all kinds of different things. So just some ideas to get you going, but there's infinite amounts of uses for this type of data. A few we've seen in the recent years here, COVID was a really interesting spot. We started to see a lot of map making, a lot of dashboards as the pandemic moved around and viruses were being tracked in all the different locations around the world. It's a really good use case for spatial data. And especially in the pandemic times, routing resources and figuring out where we needed healthcare professionals and vaccines and all these different things, spatial data plays a massive role in that. Other examples, optimizing transportation. We see this with a lot of our customers as well. So it's the idea of if I have ambulances in a city, are they actually going the right routes to get to where they need to go? Are we parking them at the right spots? Are we thinking about the logistics of all of that? Spatial is a perfect way to map that and think about it. And a final note here is that spatial is being embraced by all the different technology companies that we use and that we're seeing, and it's being embraced more and more and more. Snowflake for example, has added spatial support in the last few years. Google has been a massive innovator in this space for many, many years. I think we're all way better for having Google Maps. I know I'm much better at finding where I'm trying to go, and if I had paper maps, I'd be in big trouble there. And BI tools also have started to add really good mapping capabilities, Tableau and Click. And so we're seeing mapping and spatial and this whole world kind of growing and growing and growing. So let's talk about it in action a little bit, get to a few use cases. And I have two of these here, and then I'm going to welcome Steph to the stage, which is exciting. The first is the Halo Trust. Is anyone here familiar with the Halo Trust as an organization? Great. So for those of you who don't know, they work to clear landmines and unexploded ordnances in war-torn areas. And they've been doing this for 30 years, so this is not a new organization. And spatial is a key component to what they do. And so I'm going to talk about one of the examples where they're using our platform to help themselves, but they've been using us for quite a number of years at this point. So this is just one simple example of what they're doing. And it revolves around the Russian invasion in Ukraine. So the typical way that Halo Trust gets data is they have people actually going out to these areas, finding out where mines are, unexploded ordnances, mapping it, sending that back home, planning what they're going to do. It's very on the ground. But what happens in an active war zone is it's not safe to be on the ground. You can't actually go there, find out where this data is, and help the situation. So what they decided to do is come up with a new way to get valuable information without actually being on the ground. So how did they do that? I've got kind of an idea of their data stack here. This is in very loose terms, but the big idea is, can we scrape social media? Can we scrape data aggregators on the web? Can we gather as much data as possible, put that into our systems without actually being there? And that's what they've built. So they have workflows going into Twitter, for example, and when somebody takes a picture of a rocket that's sitting on the ground in Ukraine, there's a location attached to that picture. And what they can do is keep scraping that, putting it into their database, and now they've got this massive amount of really, really useful data so that when they can go back in and clean up the mines and ordnances, they have the information available to them. So that's one of the things they're doing. So they're doing that, and they're automating this whole system. So they're going through these different sources, pulling the new data in every few hours, and building up this big database. And the other piece that's interesting here to me is that they're also putting all the data back into a accessible way for all the stakeholders to see. So they're using a system there called ArcGIS, which they can map. They can add this visually to a place and share that amongst whoever needs to see it. So a really nice use case there. This is just a data spotlight, one of the pieces of data that they use. I thought I'd just show it to you. So this is kind of a crowdsourced, open, API-based website where they're gathering information about all these different places in the world, storing that data, and then folks like Halo Trust can come in and grab that for their own uses, which is nice. So in terms of takeaways, it's actually interesting. Princess Diana was involved with this organization in kind of the late 1990s. And this is a picture of her in Angola with the group. And I think what I've learned from that is she really helped kind of drive awareness of this and helped the organization to grow and get a lot of success, which is very interesting. But for key takeaways, I think that creative use of data is really useful. They were actually able, as an aside, to go back on the ground in about summer of 2022 and start to actually be active as different forces receded. And so this system is going to be in place in any area that they're working now. They've had success with this. It's not something that was just a one-time thing. They're going to be using it again and again and again. So that's the Halo Trust story. And the second story I want to tell is a power company in Australia. They're called Powerlink Queensland. They service Eastern Australia and the Queensland area and have 4 million or so customers across that region. And so they had an interesting project here, which is all about as natural disasters happen in an area, how can we manage it, understand it, get real-time information about it, and then allow that to help us manage our infrastructure and our assets and all the pieces that we typically have. And so in 2010, they didn't have any system at all built for this. And then over the last number of years, they've built a really responsive, useful, and fully automated system to help them manage these types of events. So it's a fun kind of diagram here. This I stole from one of their slides. But effectively, as events happen, they're able to ingest that into the system. So these are events like bushfires, for example, or floods, earthquakes. Severe weather storms are another one, or really high temperature events. And then they track that. They filter it down to make sure it's areas that they're interested in. So another idea of spatial filtering there. Where on Earth am I actually interested in the data? They're able to do that. And then the end result, which is really interesting, is they're able to notify stakeholders immediately as things happen. So they do that through SMS, through text messages, through emails. They also build maps and just reports. So as a data spotlight, I pulled out one of the sources of data that they use, which is an Australian government website that tracks all the bushfires. And they actually use satellite data to do this. So they're looking at satellite data as they see events, they're adding it to the map, and then everyone who's interested in this data across Australia can access it. So an interesting use case. In fact, almost all the data that they're using for this system is these open data portals that are provided by the government. So kind of creatively looking for where you can get data from is a really important part of this, I think. And just finally, here's some example products that they build. So this is, I guess one thing I'd say here is I probably showed a lot of maps today. You're seeing maps and maps and maps. And that's okay, but spatial data, because it's spatial, it doesn't always mean you have to build a map and show somebody this very complicated thing. It can actually just be used to make decisions. And I've got an example of that on the top right here. It's a little bit hard to see, but what it is the priority of some of their assets because there was a really high heat event in that region, and so they need to go maintain and double check some of the infrastructure that they have. And so there's nothing spatial about that in the display, but the spatial data is actually driving their decision making and their resource processes, which is great. So some key takeaways there, using open data. Again, looking for data sources, really, really useful. In both of these examples, they were creative about where data is coming from. And then I love the idea of PDFs as well. I didn't touch upon this, but PDFs are just kind of a data type we all use. We all understand PDFs. So when you're sharing data out to a number of stakeholders that may not always be technical, something like a PDF is like gold. So that's what they're doing in a lot of cases, is these PDFs are going out to internal users. Kind of funny to say. But at this point, I want to welcome Steph. And so Steph is a digital engineer on the Transport for London GIS team. And you've been using spatial data for like 10 years plus? Yeah. And so you're going to share a little bit about what you're doing with it. And yeah, thank you so much, Steph.
Yeah.
Welcome.
Cool. Yeah, thank you very much for having me. Today I'm going to talk a little bit about how Transport for London are using spatial data to kind of analyse the flood risk to our networks, our assets, and how we can make sure that we keep all of our customers safe. That's me. So this is just a little agenda of what I'm going to talk to you about today. So, yeah, who are TfL, why flood risk is important, the Lucifer project, which is where we're kind of assessing flood risk, and kind of the data and outcomes that we have from this work. So I'm sure that probably most people in the room, I hope you know who Transport for London are. But we are the transport authority for Greater London. We manage public transport and the main roads in London. So anything from the iconic Red London buses, the Tube, licensing taxis and private hire vehicles, to improving walking and cycling and making sure that we can all move around the city sustainably and safely. So that's us. And I quite like this infographic. This is kind of an asset-focused one. So, yeah, we look after a lot of different modes in London. But as well as all those kind of modes of transport that you think of, we're actually the third biggest landowner in London as well. So we're focusing every year on creating new houses for people and facilitating, I think, over 60 million journeys a day. So lots of people that we need to keep safe and moving in the city. So why is flood risk important in all of this? Obviously, as I say, we've got to keep all those people moving around London. But we also have a legal requirement to make sure that the risk of flood is as low as reasonably practical, or a LARP, we say. And this is a very real problem, so it's a bit of a dark picture in the top corner, but this is Mile End back in 2012, so that's out in East London on the Central Line. And we had a burst water main there, which meant about 30 million litres of water went down into the tunnel, and we had to suspend that part of the line for actually only 26 hours, which I thought was quite quick, all things considered. But we continue to see this as a really real problem around the world. So got some pictures here of Hong Kong and Madrid and their metro systems, which have been flooded both this month. So climate change is really coming into action here, and we see more and more risk because of that. So that forms kind of our asset strategy going forward. How can we adapt to climate change and make sure that we keep everybody safe and keep everyone moving? And this is where Lucifer enters. We love a ridiculous acronym at TfL. So Lucifer is the London Comprehensive Review of Flood Risk. So you can see why Lucifer is a lot easier to say. And this started back in 2013, so actually very soon after that Mile End event, and still ongoing. So we've been working on it for over 10 years in different phases. And the main aim of this project was to inform TfL of the level of risk that we've got across all of our modes and our critical assets. So critical assets might include things like our signals or communications. Without those, trains aren't going to be going anywhere. So there's three main types of flood risk that we assessed in this. So pluvial, that's the rain, burst water mains, pretty self-explanatory, and fluvial from rivers. So yeah, like I say, it's been quite a long project. Those bits in green we've kind of mostly finished now, and these parts in yellow are where we're kind of working today. So the project started out with assessing all 270 of our London Underground stations. Actually, in reality, we assessed over 800 separate locations because stations have multiple entrances. We've got tunnel entrances down into the track, shafts, things like that. So this is where we start pulling in that data and kind of assessing all of these locations for their flood risk. And phase 2 was to kind of look at these things in a bit more detail. So 80 of the highest risk sites, so only 10% what we looked at, actually carried 85% of the total risk that we were looking at. Excuse me. So yeah, kind of looking at these areas and what we can do to kind of bring that risk down in those areas to as a LARP or as low as reasonably practical. So phase 3 is where I entered. Hi. And then we start repeating these workflows and looking at other assets that we own. So the DLR, the London Overground, road tunnels, some of those critical asset buildings like these line-side buildings. And also start looking at other forms of risk. So track support washout, that's our picture that we've got down here. Again, that's this year up in Scotland. So if you get a build-up of water on one side of the tracks, it can start to move all that structure underneath the track and cause things to be unstable and unsafe. So we start looking at those for the London Underground. And then phase 4, again, we're just starting to do this for our other modes as well. So let's talk about data. That's why we're all here. We love data. First part of this project was kind of bringing all of our data together. TfL is a really large organization. historically we've come from different organizations as well, so what you might hold for data you might hold for one mode, you might not hold for other modes. So that was a big part of this project, was data gathering and actually getting these places into one usable data set rather than things that people have in their head. We also had a lot of third-party data that we needed to get for this. Our friends at the Environment Agency providing lots of flood risk modeling, as well as LiDAR data, because height is very important when you're looking at flood risk. Is my asset actually sort of above or below the level of water that we're looking at? So you can see we're starting to look at things like some big data, flood modeling data, big data, spatial data, APIs. And once we've got all of this data, how are we actually going to start analyzing this so we can say these assets are more at risk than this and why? So this is where FME comes into play. So we've got a screenshot here of kind of what FME looks like when you're building your workflow. So you're reading in your data sets on the left. So again, that can be anything, our APIs, our spatial data, our Excel spreadsheets, and we had everything for this project. That's always the way. And then we start to validate that data and make it so it's actually usable. I know that I probably spend 90% of my time data wrangling rather than anything more exciting than that. So yeah, standardizing that data, getting it ready to work with it. And then we can actually start to build that analysis. So bringing those data sets together, looking at those spatial relationships. Is that depot in the footprint of the flood zone? How much of the depot is in that footprint? And just start really doing some of that spatial analysis, which is where GIS really starts to shine, really. And yeah, I mentioned this has been a really long project, so I've obviously taken over from previous people, and it's been really easy to take their workflows that they've created here and just carry on with it myself to then repeat this on new modes and things like that. And I say no code. If you want to write a Python script and stick it in there, you can. We do a bit of that, but personally I quite like a nice interface like this, so it's really easy for me to pick it up and pass it on to everyone else. And then at the end of our workflow, we spit out that data to whatever people are after. So in this case, they just wanted a nice spreadsheet of data, so our kind of hydraulic engineers can go forward and do the analysis they need to do, but we can spit it out in whatever format they want. So yeah, outcomes. We set out what we needed to do. We got a good understanding and quantified the risk across our network, across all of those different modes of transport. And from that, we were then able to prioritize our investment in those kind of 80 stations that were most at risk for London Underground, for example. And I was talking to some of the flood engineers, and I was like, oh, have you got some pictures of like a nice sexy flood wall that I can put in my presentation? And it's not really like that. It's more about kind of updating our procedures, training staff about what to do in these emergencies, and making sure that individual stations have individual plans, and just lowering that risk for people when they're in those locations. We work quite a lot still with our other partners, so we're working really closely with the Environment Agency, and particularly people like Thames Waters. Obviously, we're talking about burst water mains. We all need to work together to kind of reduce the risk that we've got from these things. And yeah, we start making things like our climate adaptation plans, but also we're building a lot ourselves, right? I said to you earlier, we're huge landowners and we own a lot of the roads in London. So how can we build in what we've got on our own land to make sure that this is sustainable? And we do things like sustainable urban drainage that just sort of helps that flow of water around the city. And data sharing. So all of this information from the Lucifer project, that's all in reports online. You guys can go Google it when you're done later and see your own station and what the risk is there. But also it's about kind of putting that data in the hands of other people at TfL. Like, I'm here doing the analysis, but maybe other people can do it themselves. So we share all of this in a flood risk GIS system, and everybody can just go and look at that data that we've now finally grouped all together and start doing their own analysis when they're doing new projects out on the network. And that's all from me.
Awesome. Thank you, Steph. Ooh, lost my mic there. But yeah, as a quick wrap up, we have a great guide for dummies, but just it's about spatial data in the enterprise. So happily grab this QR code there. Suzanne at the back, who's waving her hand, has a bunch of these on a card. So if you want to grab one from her, please do that. And a big thank you to Steph, talking through their story. And thank you to all of you who have come and attended. And just final thought is, are you taking full advantage of spatial data? Are there better ways to utilize it? Thanks. That's it for us.